Welcome to Supermath, where math gets easier one problem at a time. In today's lesson, we're diving into measures of positions. So this is essential tools for understanding how data points relate to each other within a set. So we will cover percentiles, quartiles, and everything in between. So whether you're preparing for an exam or just brushing up on your stat skills, this video has you covered. So grab your notes and let's get started. A measure of positions determines the positions of a single value in relation to other values in a sample or population datasets. It means it refers to statistical tools that describes the relative standing or the rank of the data value within a dataset. So they help to identify where a particular data points lies in relation to other values. So the most common measures of position, that is our quartile, decile, and percentile. Okay, so let's start with the quartile. So in terms of quartile, that is our data set is divided into 4 equal parts. While in decile, it divides the data set into 10 equal parts. And in terms of percentile, we divide our data set into 100 equal parts. So for example, in quartile, we have 12 data values and divided into 4 equal parts. That is why we have 3 members each division. So we have the first quartile, the second quartile, and we have the third quartile. And our first quartile, that is our lower quartile. And second quartile, that will be our median. And third quartile, that is our upper quartile. And because we divided our data sets into 4 equal parts, that is equal to 25% of our data. So in terms of decile, we divide in our data set into 10 equal parts. So that is 10% of our data. That is why we have here the first deciles, the second decile, third, fourth decile, and so on. So in terms of percentile, we divide our data sets into 100 equal parts. That is why that is 1% of our data. So in terms of our formula, for the ungrouped data, for the quartile, that is Q sub k is equal to k over 4 multiplied to n plus 1. So as you can see right now, we have ungrouped data simplified form for the first quartile, second quartile, and for the third quartile. Okay, so when calculating quartiles, specifically the first quartile and the third quartile, there may be cases where you end up with a non-integer position or ranking. When identifying where this quartiles lies in your dataset, here's what rounding up for first quartile and rounding down for the third quartile means. Okay, for the rounding up for the first quartile, that is the value that corresponds to the 25th percentile in your dataset. So after you sort your data, if the position you calculate for the first quartile isn't a whole number, for instance, if the rank is equal to 3.2, so round up to the next whole number, in this case, that is approximately equal to 4. So the value in the fourth position of the sorted dataset will be your first quartile. So this ensures that the first quartile falls in the upper portions of the lower half of the data. While in the third quartile, that is the round down. That is the value that corresponds to the 75th percentile in your dataset. So similarly, if you calculate a non-integer positions for the third quartile, for example, 6.8. So we are going to round down to the nearest whole number. So in this case, round down 6.8, that is down into 6. So that is approximately 6. So the value in the 6th position of the sorted data set will be your third quartile. So this ensured that the third quartile falls in the lower portions of the upper half of the data. So why round up for the first quartile and down for the third quartile? Why we need to do that? So those numbers or this rounding method ensures that first quartile tends toward the lower range of the data, while the third quartile tends toward the higher range, giving a better balance when dividing the data into quartiles. It's a convention to maintain consistency in how we interpret the distributions of our data. Okay, so for the median, it also known as the second quartile. So the process is a bit different from the first quartile and the third quartile because it represents the middle value of our data sets. So here's how it works. So there is no rounding off, rounding down, or rounding up. The median is the 50th percentile, dividing the data into two equal halves. So the approach to finding the second quartile depends on whether you have an odd or an even of the data points. So for an odd number of data points, the median is simply the middle value. For example, if you have 7 data points, after sorting them, the median is the fourth positions. Okay, for an even number of data points, the median is the average of the two middle values. So what are the key differences? Unlike Q sub 1 and Q sub 3, when you round up or round down when calculating non-integer positions, you don't round the position for the median. Okay, if you have an even number of data points, the median is calculated as the mean of the two middle values to maintain accuracy and represent the true central tendency of the data. So now let's take a look for the formula for the decile of the ungrouped data. So that is d sub k is equal to k over 10 multiplied to n plus 1. So that is also the same thing in percentile. But here, p sub k that is equal to k over 100 multiplied to n plus 1. So let us try a given example. So using the given data, 2, 3, 18, 26, 5, 15, 12, 10, and 8. So we are going to find the following: the first quartile, the 8th decile, and the 54th percentile. Okay, so let's take a look for the first quartile, which is that is 0.25 times n plus 1. Okay, so let us simplify. How many data values do we have here? That is 10. So that is the value of our n. And our 0.25 times 10 plus 1. So that is equal to 0.25 times 11. And that is equal to 2.75. Remember, if we have a lower quartile in terms of quartile, we have to round up. So 2.75, that is approximately 3. So that is in the third location. So therefore, the value for the first quartile is equal to 5, which is that is the third position value that we have. So now let us take a look for the 8th decile. So the same thing, we use the formula for the decile, so that is d sub k is equal to k over 10 multiplied to n plus 1. So what will be the value of k here? So k here, that is the positions that we are looking for. So k is equal to 8. And our n, that is equal to 10. So now let us simplify this value. We have 8 over 10 times 11, and that is equal to 8.n. So rounding up, so that's approximately in the 9th position. So that is equal to 18. And the same thing we are going to do for 54th percentile. So we have p sub k is equal to k over 100 times n plus 1. So our k here, that is 54 because that is the position that we are looking for. So our n, the same thing, that is equal to 10. So let us just substitute the value of 54 divided by 100 times 10 plus 1. So simplify that. We have 5.94. And that is approximately in the 6 positions. Okay? So what value is that? That is equal to 10. Now, let's take a look for the group data of measures of positions. So these are the formula for the quartile, decile, and percentile. So for us to have a deep understanding on how we're going to use this formula, let us have an example. The data shown in the frequency are the distribution scores of 40 students in a mathematics class, consists of 60 items, and we are going to find for the first quartile. So by this given, we have the class limits and also the frequency. Okay, so we are going to use this formula as you remember. For the formula for the first quartile, that is q sub 1 is equal to lower boundary plus k multiplied by n divided by 4 minus cumulative frequency over the frequency multiplied to our interval. Okay, so first thing, because we need the cumulative frequency in our given data sets, so now let us take a look for the cumulative frequency. How are we going to find the cumulative frequency? So for completing this table, first on the first row, let us copy the frequency of our first row, which is 5. For us to find the next cumulative frequency, just add the next frequency. So we have 5 plus 2, that is equal to 7. And then 7 plus 3, we have 10. 10 plus 5, we have 15. 15 plus 2, that is equal to 17. 17 plus 9, that is equal to 26, and so on and so forth. Now we have until 40. That is why the total number of frequency that we have is equal to 40. First thing, for us to find the lower boundary, the cumulative frequency, the frequency, and the interval, we must find out first the rank value. Okay, for us to find the rank value, that is k multiplied by n divided by 4. Okay, that is for the q sub 1, that is our rank value, kn over 4. So what is the value of k here? Okay, the value of k here is equal to 1, which is that is the position that we are looking for, the first quartile. That is 1 times 40, that is the value of n, which is 40, divided by 4. Okay, so that is equal to 10. So by this given value, we have 10 for the rank value, which is for us to look on the table, we are going to look for value that is greater than or equal to 10. So on what row we are going to choose for us to have the rank value? So in this highlighted color, which is yellow, so that will be our rank value. We are going to base all the values for the lower boundary, cumulative frequency, frequency, and the interval by this row. Okay, so that will be our rank value. So what will be our lower boundary? Okay, as we remember, lower boundary is equal to the lower limits minus 0.5. Okay, so what will be the lower limits on this rank value? Okay, so that is 20. So we have 20 minus 0.5, that is equal to 19.5. So therefore, the lower boundary of this data is equal to 19.5. Okay, so let's take a look for the cumulative frequency. But remember, cumulative frequency is the cumulative frequency before the rank class. Okay, what is the rank class here? That is highlighted in yellow. So what will be the cumulative frequency? So that is equal to 7. Okay, that is the cumulative frequency before the rank class. Okay, so our frequency, that is the frequency of our rank class. So that is equal to 3. Okay, now we are going to look for the interval. For us to find that, let's take a look for the lower limits of our each row. So we have 50 minus 45, we have our interval, which is equal to 5. So our lower boundary is equal to 19.5, cumulative frequency is equal to 7, frequency is equal to 3, and our interval is equal to 4. So now let us just substitute those values in our given formula. So for the lower boundary, that is 19.5. For K, that is the position we are looking for, the first quartile. That is why the value of K is equal to 1. So now we have 40, that's the total number of frequency, and divided by 4 and subtracted by 7, that is the cumulative frequency of our rank class, and divided by 3 and multiplied by 5. So simplify this term. So let us simplify first the inside value in the parentheses. So that is equal to 1. Okay, so now we have this given equations. Q sub 1 is equal to 19.5 plus 1 times 5. And that is equal to 24.5. So therefore, the 25% of the score are less than 24.5. Now let's take a look for another example. So in this table, this is the same thing that we used earlier, and now we are going to find the fifth deciles. So as you can see, we evaluate the cumulative frequency, which is denoted as 5, 7, 10, 15, 17, 26, 32, 35, and then 40. So first thing, if you remember, we need to find the rank value. So that is Kn divided by 10. So what will be the value of K here? So that is 5, because that is the position that we are looking for, the fifth decile. So that K is equal to 5. So our N is 40, so divided by 10, that is equal to 20. For us to find the rank class of this given data table, we are going to look for greater than or equal to 20. So what do you think will be the value or the rank value we are going to look for here? So that is highlighted in yellow. So that is 35 to 40, the class limit, the frequency is 9, and the cumulative frequency of that row is equal to 26. Okay, so let's take a look for the lower boundary. So remember, that is lower boundary is equal to the lower limits minus 0.5. So what will be the lower limits in this row? Okay, so that is 35. So 35 minus 0.5 for us to find the lower boundary. So that is equal to 34.5. So therefore, the lower boundary in this given data sets is 34.5. Okay, now let us take a look for the cumulative frequency. But take note, that is the cumulative frequency before the rank class. So that is equal to 70. Okay, how about the frequency? So frequency here, that is the frequency of the rank class. So that is equal to 9. So the interval, that is the same we did earlier. So that is I is equal to 50 minus 45. That is equal to 5. So that will be our interval. So by this values gathered, so let us just substitute those values in our formula. So we have 34.5 plus 5 times 40 divided by 10 minus 17. Okay, so that will be 3. Okay, so divided by 9. So we will have 3 over 9 times 5. Okay, so we just simplify the value inside the parentheses. Okay, so simplifying this, that is equal to 36.7. So that will be our decile 5 or the fifth decile. So hence, the 50% of the scores are less than 36.17. Okay, now let us take a look for another example. So we are going to find here for the 85th percentile. So that is the same thing we are going to do in this given example. But right now, we are looking for the 85th percentile. We are using the percentile formula. So that is equal to lower boundary plus K times N over 100 minus cumulative frequency divided by the frequency times the interval. First thing, let us look for the rank value. So that is Kn over 100. Okay, so what will be the value of K here? That is equal to 85, because that is the positions that we are looking for. So 85 times 40, So 40, that is the total number of frequencies. So divided by 100, that is equal to 34. So we are going to look again for the rank class. So that will be greater than or equal to 34. So what will be? So that is the highlighted color again. So 45 to 49, that is the class limits. The frequency is 3 and the cumulative frequency of that row is equal to 35. So using our formula, let us find for the lower boundaries. As we did earlier, that is equal to lower limits minus 0.5. So what will be the lower limits on our rank class? So that is 45. So 45 minus 0.5, that is equal to 44.5. So that will be our lower boundary here. So now let's take a look for the cumulative frequency. As we said, that is the cumulative frequency before the rank class. So that is equal to 32. Okay, so let's take a look for the frequency. So that is equal to 3. Okay, how about the interval? So the interval that is we did earlier, which is I is equal to 50 minus 45. So therefore, the interval of this given data set is equal to 5. So by data gathered we have, let us just substitute those value into our formula. So we have right now 44.5 plus 85 times 40 over 100 minus 32. So divided by 3, multiplied by 5. So simplifying those value inside the parentheses, that is equal to 2 over 3. So multiplied by 5 and then added 44.5, that is equal to 47.83. So thus, this is the 85% of the scores that are less than 47.83. So thank you for watching for this Supermath video on measures of positions. So getting the hang of percentiles, decile, and quartiles can be challenging, but I hope you now feel more confident in using these tools to break down and interpret our data. If you found these lessons helpful, don't forget to like and subscribe for more math tutorials. Got questions or need more clarifications? So drop them in the comments. So I'm always happy to help. Stay curious, keep practicing, and I'll see you in the next Supermath video. So bye for now.